Today, I'm happy to be here to talk about the project we did in our laboratory in Lut University titled Insight into the Hydrogen-Assisted Static Crack Growth in Carbon Steel Grades, a Machine Learning Approach. So, actually, at first, I would like to say a short introduction about the hydrogen embrittlement and also some challenges we face. However, in nowadays there are lots of tests and we face lots of data, but we need some kind of analysis to know how we are able to know the hydrogen embrittlement phenomena. For example, in the pipeline, it's really important to know about the reliability and reduce the risk of the catastrophic failure, and also ensure that the grades used in such application are suitable for the long-term service. And this is really important for us about the long-term service, because it's nowadays really difficult to do some kind of tests in laboratories and academic area. In this study, we try to introduce a model that is related to the machine learning, and we try to extend it in the future, maybe to deal with kind of challenge like the long-term service with the prediction. So let's talk a little bit about the study aims and also the machine learning. This study tries to predict the fatigue crack growth rate, FCG rate, using some parameters we collect from the database. As I mentioned, nowadays we have lots of data, and let's to say correct data that we are able to use them to analyze the data and know the phenomena better. However, we need some experiments to prove the model, but the majority of the model is based on the literature review and some data we got from another researcher. And in the machine learning, there are some goals such as pattern identification, phenomena understanding, and pattern assessment. And the last one is the most important thing we would like to focus in this study, that is what machine learning techniques can be used to assess and evaluate the various parameters that influence the hydrogen embrittlement pipelines. And about the machine learning, however, it's a technique, but it includes many different areas, such technology, clustering, algorithm, data analytics, engineering, and computer science. That is why we need a team to do this kind of techniques. And on the other side, all of them should be correct, that we get the output correct. Nowadays, we collect data, use the clustering, and use the engineering in our team, and we are trying to find some accurate algorithm to data analytics. So the methodology that we start to use in this study starts with the data collection. It's one of the most important sections we use because if the data collection is not correct or it's inappropriate, we face some output that they are not so suitable. So in the data collection, we have two kind of parameters, the constant and the variable. The constant is based on the standard ASTM that you can see here, but the variable that it's more important for us in this study is the yield stress, tensile stress, chemical composition, and pressure of hydrogen. So during the data collection, we try to look at the standards and also try to look at the chemical composition of the material we collected from the literature to make sure that the data collection is true and we are able to make our data set based on that. And after that, start the prediction, and after that, the prediction. In the methodology, second step, data analytics. Application of the feature selection techniques that is included a study of effect of each parameters of FCG, finding the key factors influencing FCG and effect of critical alloy elements on FCG. However, at the first glance, you can see this is the huge goal in this field, in the hydrogen embrittlement, to know which alloy elements is the most important and key factor, but we try to go a little bit narrow into the pipeline and also some material that used in our database. And another matter we face it is which kind of technique we have to use in the machine learning, because machine learning itself included several techniques, and using of them it needs some time and it's a little bit time consuming. However, in the first step we used some error metrics, some MSC and RMC, and using these two kind of parameters and criteria to use the model, and after that go further and look at the trends that we have in the output. And after the validation, we make a decision which kind of the techniques would be used in our prediction. So in the third section, after the data analytics, we come to the prediction. And the application of machine learning, it's about the development of the predictive models, assessment of the various models, and verification of the development after the using the literature review, and after that make the data set, choose the techniques, and then start to develop the predictive model. Here we can see some prediction about the FCG rate, and we are able to see this model can predict this rate. However, we have to consider that FCG rate nature that already has lots of influctuation. So there are lots of go up and go down in the data. So we have to know the nature of the data, and after that expect the results. So in the and we are able to see the training here, and we can see the database trained based on the data. And so let's go to the next slide. Here we can see some tests here. There are some data that they didn't participate in the validation and also to the training, but the model we developed, we could predict this rate. And one of the most important things in the machine learning and output is the verification of the model. Without the verification, we are not able to know the model work well or not. So in this way, we use some feature of the machine learning. For example, by machine learning, we try to know which elements can impact on the hydrogen embrittlement, and which one is positive and which one is negative. And after that, we try to find the validation for this kind of alloy elements effects on the output. And also, we try to have a look on the influence of the pressure of the hydrogen tensile stress or yield stress. As an example, we can see that some references that we provided here shows that the model based on this kind of data we collected can work somehow, and it can tell us that the machine learning and the model can help us to know the nature of the hydrogen in the embrittlement, and also it can help us to know better the phenomenon. And also here we are able to show what is the impact of each alloy elements on the output. Of course, here we can see the effect of the alloy elements on the output. But one of the another thing the machine learning can tell us, and it's really we are really interested on that. It's the interaction of the parameters on the output. So let's have a conclusion. The first thing is that the machine learning serves a valuable tool for predicting cracker rates in pipeline steel and investigating the essential parameter associated with the hydrogen assisted fatigue. And the second one is that the behavior of the crack grow in the pipeline can be studied using the machine learning under the various situations. And another one could be the further exploration of the machine learning application in studying hydrogen environment embrittlement in pipelines should focus on the interaction between the parameters and the material behavior with the environment. We have the hydrogen in it. And the last one that it could be output of our study is that the machine learning can be utilized to evaluate the alloy elements in pipeline steam, allowing the reassessment and the redesign of the pipeline, especially when considering the hydrogen environment. For example, the outputs that with validated with the standards can tell us that reducing the S elements in pipeline can help to reduce the risk of the hydrogen embrittlement. And of course, this is a long way to apply this machine learning because nowadays we know in the industry and also for the design for the future, we need validating all of the data. Thanks for your consideration.